Hi everyone, we're here with Professor Stephen Williams of Southern Technical College, and we're going to give a demonstration for electrical motors and controls.
Hi, it's Tuesday, it's about 2 o'clock, not quite, and let's see, it's the 12th of June, or May. Ugh, close. Anyhow, I know you've been getting a little bit sick of just reading and seeing things, so I decided today to do a little video. One of the things that I did with the last classroom while they were here, however, that's not possible at the moment, so we're going to do it on tape, okay? With that in mind, I want to try to tie a bunch of things together today. We talked about wiring diagrams and different stuff, controls, motor controls, how, you know, you've got a motor portion or a high voltage and a low voltage portion, okay? We're going to try to make a little bit of sense out of that, all right? So with that in mind, over here we've got a motor. It's nothing fancy. It just happens to be a 1/3 horsepower motor. Why? Because smaller motors are cheaper. And in this case, we're at a school that doesn't have really access to any power besides 120 volt. Not that I can't boost it up, but that takes a little bit of doing. So anyhow, I work with what I've got. In this case, I've got 120 volt. This is a motor that's designed for operation at either, let's see, we're looking at the motor nameplate here.
That's 1/3 horsepower where his thumb is. Voltage is 115. Amps is 7. RMP 1750. And it says
RPM.
yes.
Okay, and the bottom line is it's basically just one I bought off the internet. It happens to be what they call a split phase motor. Okay, if you look over here, it's a split phase motor that basically is designed to be able to start, because a typical single phase motor just by itself won't roll. You have to get it started. So they use a thing we've already talked about a little bit. We'll be getting into it in a later chapter a little deeper. But the bottom line, you have to use a system that will get it rolling. We also have over here a motor starter, which is what? A contactor, combination of a contactor and an overload relay. Okay, this particular contactor is designed for this specific motor. In other words, it's designed for a 1/3 horsepower motor. And again, we'll talk about more of that later, but that's what we're going to start out with. All right, so
So is that a breaker I see in there? This little green switch here?
no,
What is that?
this happens to be a start push button.
Oh,
Okay, and this happens to be a combination stop push button and also a reset. If the overload relay would trip it, you would reset it with this button also. So it's a combination type thing. But we're not going to get into the details of that yet, because we'll do more of that tomorrow. All right, and we'll go over that in a little more detail. But before we go anywhere, let's talk about what we've been studying is drawings, all right, and components shown on drawings. And with that in mind, we're going to do a ladder diagram, and we're going to do one associated with this motor and this starter. All right, so with that in mind, we're going to start with what? I've got voltage then. Oops. Sorry guys, I haven't tested these yet. That's better. So we've got L1 coming in and L2 coming in, and between these 2 points we've got 120 volts AC. All right, so we need a way here. Number one, we need to feed a motor. So what are some of the components I'm going to need? Well, let's say to start out with, I'm going to need to disconnect the motor, you know, to be able to turn it off and on, right? Well, I'm gonna be using a starter for turning the motor on and off, but I also need a means of disconnecting the power to the starter. So I'm gonna come in here, okay, and I'm gonna add a switch in here. And again, I'm using what I've got. So I happen to have a selector switch, okay? And it's a 2-position selector switch. And it's got position number 1, which is off. And over here is position number 2, which is on. All right. So now I have a means of disconnecting the power to the starter, but I also need now something to protect the whole circuit for short circuit. All right. So we're going to be using number 14 wire. So therefore I'm going to use 15 amp fuses. All right. Because that's what the code dictates. Now in this case I'm going to be using what they call slow blow fuses, because I want to get to a point where I can start up the motor without having nuisance trips. And if you get a fast blow, it's going to have a tendency to trip before you ever get the motor started. So a slow blow fuse, or another kind would be a dual element fuse, would be the best thing to use there. So we're going to come up here and we've got a terminal block, and essentially we're going to use the symbol for a fuse, all right? And we're going to call that F1, and that's going to be 15 amps, all right? So what else do I need? In other words, this fuse is going to take the place of a breaker. If I had a breaker, it's got a built-in disconnect switch. I could use a breaker from a distribution panel, but in this case I'm building a starter and I want to mount it right on the starter itself, all right? So with that in mind, I'm not going to fuse, because this is going to be phase and neutral, all right, which ultimately is grounded. All right, so I'm not going to fuse the grounded side. Some people elect to, other people don't. It really isn't required. Now, the next thing is I need some way to pick up the power that's going to go to the starter, okay? And typically what you've got is a motor starter. Going to the motor, okay. I've got a motor starter, and down here I'm going to have the other contact, because it's a 2-phase starter. And attached to the starter I have the overload relay. So I'm going to show the overload relay element, which again is another connection in there. And typically they show that with 2 back-to-back quarter circles. Okay, and we've got 1 in each.
Kind of looks like a C going one way and a C going the other.
Oops,
No, those 2 C's are going the same way.
sorry.
There we go.
Nothing sacred about them. All right, and from there, typically you're going to feed the motor itself. So down here I'm going to have my motor, and it's going to have 2 connections. We're going to call them T1 and T2. And typically these connections are also called T1 and T2 at the starter. We zoom in on that, I think you'll find that there. It's kind of a little hard to see. I don't know if you can zoom right in on those little letters there.
On the little letters, where it says 96 NC, 98 NO, 97 NO, and 95 NC.
Actually down here. on the very bottom. It should be these two connections.
Oh. I don't barely see the numbers on there. I see a 4 and a 2.
Anyhow, they're going to be T1 and T2. So anyhow, what we have here is the portion of the power.
Barely
circuit.
see it. See the 2. Okay. Anyways.
What we have on the board right now is the power circuit. Okay, and like I said, we could put another fuse in over here, but it's not really required on the neutral side. All right, so this is part of the overload relay. So we're going to call it thermal overload. Okay, thermal overload. And this is part of the motor starter, which we generally designate as an M. And typically what I see on most of the drawings is a horsepower size, telling you what size it is. In this case, it is 1/3 horsepower. All right, which tells you it's a motor. All right, now we have 120 volts coming in, but all the controls I have are 24 volt AC. So with that in mind, we have to reduce the power. So we need to come over here, and we're going to tap off of these lines. Okay, we're going to tap off at this point below the fuse, because if that fuse blows, I want to know it. Okay, so over here I'm going to tap off, and I'm going to tap off like here. We'll just tap off the line right here. Okay, and I'm going to go to a control transformer. Now, this particular control transformer that I have is a dual voltage input. It has 120 or 240. You can use either one, or 110, 220. All right, so it's got a coil. And another coil. Okay, and this is typically H1, H2, sorry, H2, and then this is going to be H3 and H4. Okay, and since I'm connecting it at 120, all right, if I was connecting it at 220, all right, or 210, or 240 or whatever, if I was connected at the higher voltage, I'd want to use both of these coils in series. But since I want to connect them up at the lower voltage, I connect them in parallel. So with that in mind, essentially, okay, I want to connect these together. And when I connect them together, I should get two parallel circuits, or I'm sorry. Anyhow, we'll get back to that. All right, but on the other side, I'm going to have a single coil coming out. And I've got a X2 and an X1. Okay, the X2 is going to be tied to the neutral. And remember from our studies when we were looking at transformers, which we just did yesterday, with the control transformer, we want to ground the neutral side of the control transformer on the output. So we're going to come here, and we're going to have a ground. Okay, and we're going to be coming off of here with a fuse. And this happens to be, okay, this is going to be 110, 220 volt. And this is going to be 24 volt. All right, and we're going to fuse the phase side of the transformer. All right, and coming out of there now, I'm going to have basically what we call L1, and this is going to mess things up, but and L2. I should have started closer to the other side. Such as life.
Do you have that on that paper?
All right,
Because we could zoom in on the big picture if you do.
we will.
Okay.
All right, so now we need to figure out what we're going to be doing here. All right, so we've got the power end of it set up. You know, that's easy enough to do. We've got the transformer set up. And essentially this here, sorry guys,
Continue.
is going to be L2 coming down. And this is L1. Okay, and essentially, first thing we need to concern about is how am I going to turn it on and off? All right, so let's start with a push button. In this case, two push buttons. And we'll go over there, and this is a stop. This is a start. And if you remember, when I push down, it's a momentary push button. So when I push it down, it's going to spring return back to the open position. All right, so I push it down to close it, but it's going to spring return. So I need a way to get around that. So in this case, I'm going to put a contact in parallel with it. And that contact is going to be my hold-in, so that when I start it, it's going to hold it in. And I'll explain this a little bit later, but I'm going to call it CR1, TAC 1. All right? Over here, at this point, I want to pick up my starter coil. Okay, and we're going to call that M because it's associated with the motor starter. Now, I also want to have a contact over here from M. I'm going to call that M-1. Now, unfortunately, I only have one contact on this particular motor starter. That's why I'm using that to do what? To pick up a relay. That relay is going to be CR1, I'm sorry. We're going to call it CR1. And that CR1 TAC 1 happens to be a contact off of that relay. So the idea is, it's not the perfect scenario, but with only one contact on your starter, you're kind of forced to work around it, which is good because otherwise I wouldn't be able to show you what the CR relay would kind of be used for. Now, the other thing I want to do is I want to pick up, when I pick up this, I want to put another contact out here. And I want to know when my motor has picked up. Well, when the motor starter picks up, the auxiliary contact picks up, in this case, it's energizing a control relay. And because it's energizing a control relay, that's picking up at the same time that I want to know so out here, I want to put an indicating light. And I want it to be red, because I want it to say, hey, the motor's running. Now, it has to be normally open because I want it to light up after the CR1 relay picks up. So normally open it is, but I also want to know when it's off. All right, so let's come over here. And again, remember, the dot on there indicates that it's an actual connection in the diagram, right? So I'm going to come over here also and put another contact in here off of CR1, but this one I'm going to make normally closed. All right, and again, now I want to put another light over here that says that the motor is off, or it's safe, it's green, okay? So with that in mind, I'm almost to the point of what I need. However, I also want to know when I've got power. In other words, I want to know that my selector switch, and again, I didn't name this, I'm going to call it SS1. All right, selector switch number 1. All right, and it's currently in the off position. So when I take it to on, I want to know about that. So one easy way for me to do that is I can just come down here and let's just come up here and put another light. In this case, let's make it a white light. And we're going to call this power on. We're going to call this one motor on. And we're going to call this one motor off. All right, fairly simple one, and again, this is off of CR1, but it's the third contact off of CR1. So, what else could we have? Let's see. If I want to be creative, let's suppose I wanted a limit switch to shut it off or I should say all right, so let's call this LS1. and it's going to be normally closed and then open when I get to some point that I want to turn the motor off. Now, the other thing I have is my overload relay, and what I prefer to do here, a lot of times they'll show that contact from the overload relay when it trips here on the motor. My preference is to put it right here, okay, where I'm coming off the fuse. And it's going to be a normally open contact. And when you pick up, I'm sorry, it's a normally closed contact. And when the thermal overload elements trip, okay, this contact will open. It'll shut off the power to the whole control system. Okay, that's the ideal thing I want to do. So I want it to open up right there at this point. This fuse, I'm going to make this, okay, this happens to be 100 VA as far as the size of the transformer. Now, technically, it's got a magnetic core, and we show the magnetic core here. If it's 100 VA, and I've got 24 volts AC, I'm going to fuse it at, let's say, 5 amps. Okay? So I'm going to make this a 5 amp fuse. Okay? And again, just so that we don't forget, I want to make this a slow blow. And same thing over here. I want to make this a slow blow. Because there's inrush here, and you want to get past that inrush. Now, the motor itself has a full load current of, I believe, 7 amps. Marissa, you can verify that for me.
Is that the SFA? Or I'm sorry, amps, 7, yes.
One more thing I'm going to put down here is another contact off of CR1. So when I pick up the motor, I want it to run for a certain amount of time. Okay, so in this case, I want it to run for, let's say, 5 minutes. Okay, so I'm going to make this, it's going to be a normally open closing when it gets energized. Time delay relay. Okay, and I'm going to have 5 minutes as a set point. Time delay pickup. In other words, it picks up as soon as it's energized. The coil, as soon as the coil is energized, it starts timing. Once it times out, this contact is going to change state. Or I'm sorry, this contact, which is what I'm going to put up here, TDR TAC 1, okay, is going to be normally closed, meaning that it's not in the circuit until the time that this times out. And once it times out, at that point, I want to shut the motor off. Either it's reached its limit, okay, in which case it'll shut off via the limit switch, or it'll time out after 5 minutes and turn itself off. Okay, so one more thing. CR1-4, the fourth contact. And again, that's normally open. So let's see what we got over here. I've got a motor starter, and I've got 4 contacts. So I've got contact 1, 2, 3, and 4. CR4 is normally open, 3 is normally closed, so we show that with a line under it. Okay. 2 is normally open, and 1 is normally open. So therefore, 3 normally open, okay? And now, I have to go back and number things here, all right? And I'm going to call this tier 1, or I should say rung 1, 2. I'm going to call this 3, 4, 5, 6, 7. All right, so the normally open one is in rung 3. Then I've got another normally open one down here in rung 2. I'm sorry, in rung 5. I've got a normally closed one in rung 6. And in 7, I've got a normally open one. So that tells me where my contacts are associated with, I'm sorry, that's going to be for CR1, which is 3, 5, 6,